and I'm going to be talking about rocket fuel. Alright, so rocket fuel can be represented by the combustion reaction below, which is 2H2 liquid plus O2 liquid yields 2H2O gas as well as heat. And as you can see, the reactants are in their liquid form and the product is in a gas form, and we'll talk about more why this is later in the video. Alright, so as you can see on the left side, that's a liquid fuel rocket, and on the right side is a solid fuel rocket. And the modern rocket is more of a liquid fuel rocket, so as you can see, the liquid fuel is stored in one chamber and the liquid oxidizer is stored in another, and then this goes through the pumps, the combustion chamber, and hot gases are released from the bottom, which boosts it into the air. So today we use liquid fuel rockets. This reaction heats the inside of the solid rocket boosters to more than 5,000 degrees Fahrenheit. This causes the water vapor and nitrogen to rapidly expand. The nozzle funnels expand gases outwards, creating a thrust and lifting the rocket from the launch pad. So I'm going to talk about some of the background of rocket fuel. Solid rocket fuel is the original rocket fuel, and this dates back to the early fireworks developed by the Chinese centuries ago. Aluminum powder serves as a fuel and a mineral salt. Ammonium perchlorate is the oxidizer. Rocket boosters tower more than 17 stories tall, and they burn 6 tons of solid propellant each second and help SLS break free from the clutches of Earth's gravity. Alright, so I'm going to talk about aluminum and its importance. Aluminum is highly reactive and abundant. Aluminum is so reactive that it's not found naturally in its pure form, but only in combustions with other minerals. So this ability to combine with other metals makes aluminum very useful. Ammonium perchlorate is the salt of perchloric acid and ammonia, and it's a very powerful oxidizer. When it burns oxygen from the ammonium perchlorate, it combines with aluminum to produce aluminum oxide, aluminum chloride, water vapor, and nitrogen gas, and these have lots of energy. Alright, so it's a combustion reaction, and it's a chemical reaction that allows hot gases to shoot out of the end of the rocket with enough velocity to unshackle from Earth's gravity. Alright, so combustion releases energy, which makes things go, and then the fuel is the oxidizer, which makes things burn and gives you a propellant. When heat and energy is given, it is released along with some byproducts. Alright, so I'm going to talk about liquid engines and their importance. To have enough power for a large combustion reaction requires an incredibly large tank to hold it. So if we were to use gases as the reactants, it would take up a lot of volume. So this is basically why we use liquids. But in order to use liquids, we have to cool down each reactant to a certain temperature, and that means hydrogen has to be at negative 423 degrees Fahrenheit. Alright, and on the other hand, oxygen needs to be at negative 297 degrees Fahrenheit to be in their liquid forms. So they have to be cooled down to a certain temperature, and this allows them to be stored in the tank so that there's enough of each of the reactants to create the products. Alright, this reaction releases massive amounts of energy and superheated steam. The hydrogen-oxygen reaction generates tremendous heat, causing water vapor to expand and exit the engine nozzle at speeds of 10,000 miles per hour. All that fast-moving steam creates a thrust, and that propels the rocket from the Earth. Alright, so that concludes our video.